Welcome back, and before the break we talked a little bit about genetically modified organisms and genomics, and Colin, I'm going to put the question over to you of explaining the relationship or non-relationship between those two concepts. I mean, we hear a lot about GMOs in our products. Now we've got this other concept coming in. We want to help educate the viewer now of what those two concepts mean, and is there a relation between them?
Okay, great. So genetically modified organisms implies that you're taking the genetic information from one organism and transplanting it into a new organism.
So traits,
for example, in plants, a common thing would be to take a disease-resistant trait that's common in one variety of plant and adding it to another variety of plant, so that new plant will also have that resistance to disease, which is great because if you plant that new plant, now will survive better and you'll harvest more, and it's more productive for the farmer.
And that plant is, the genetic structure is altered.
It's altered because it now has genetic information that typically wouldn't be there. And it's dramatic because it's also usually genetic information that's not easy to breed into, right? It may come from a completely different type of plant. We could be transplanting alfalfa genes into wheat genes. So we can't normally select for that and breed that, but we can take the genetic information using biotechnology and put it in there synthetically, and that's where there's some people are afraid of the technology because they don't know, are we transplanting the right type of genes, are we changing the wheat so much that it's no longer going to be wheat, does it bring in other traits that we don't understand? So there is some hesitancy from consumers
definitely
to go down
some
that.
Big perception issues there too. So how does genomics relate or differ from that?
So genomics, the technology we use, doesn't involve any sort of transplantation. Genomics really just identifies the traits within that plant. So for example, if we say wheat, what we would do is we would genetically understand what one strain of wheat is, we'd understand the other strain of wheat, and we would breed for a better trait. We do this in plants, and now we can do this in livestock as well.
So it's an approach that we've been probably using 20, 30 years ago for selecting and creating new varieties, certainly in our plant agriculture, right?
Absolutely, and even in animal breeding, we've been selectively breeding better animals since the 1800s. And we've been identifying the traits, which are often larger, more yielding cattle, and breeding them with the other large cattle, and we end up with a bigger offspring. What genomics now is doing is adding more information to select with.
Okay, so with that additional information, do you see the need for GMOs to continue to exist, or is that still a good approach, or we're not going to get the production we want without them? Can we get there with genomics?
So in plants, for example, it really is helping reshape how we do agriculture. So we really can't get certain resistant traits into new species, and that's really benefited and increased the production worldwide. In animals, it's a little more costly to do that transplantation, and it's at this stage of the technology, it's much more effective just to selectively breed for traits, because we're not trying to infer certain resistance traits in trying to get one species into another species. So for example, we're not going to breed I don't know, a human trait into a cattle so that we can get better, a smarter cow.
A smarter cow.
There's no really impetus, no real need to do that. Genomics is really just helping us breed better cows by understanding the cows that we are breeding at a genetic level.
So this is all about information, having the best information. So let's go back to cattle for a second, and we have some trait databases called EPDs, Earned Progeny Differences, and ERTs, Economic Relevant Traits, and that's a grouping of traits by breed associations about how the performance of a certain breed is doing. Now we have the ability to have some trait-specific reporting to overlay on that. Tell us about that, Tom.
Yeah, sure. So, like Colin said, we've been trying to select the best cattle for years, and we've been doing that mostly by observing the animal, whether it happens to be survive the winter well, if it grows very fast, if it has a high production of milk. And we've done that through physically observable traits.
Yes.
Now what we're able to do is analyze the genetic component of that with DNA, overlay that information onto these observable traits that we're already doing, and get more confidence in the animal's genetic ability to exhibit those traits in its offspring.
Okay.
The other thing that genomics is offering is that we can do that at a very early age. So, for example, it takes a long time to raise a breeding heifer to breeding age and then get your first calf.
Okay, and
right?
How long is that?
So 3 years.
3 years, okay.
Yeah. So if you can identify whether that heifer is actually going to be fertile when she's only 2 months old, you can save a lot of time by not even bothering to raise her to that age.
Absolutely.
So that's a significant savings for the producer, and we'll be able to do that with genomics, and in some cases we can do some of those things already, and we think that's going to just get better as we understand DNA and we're able to attribute these markers to certain traits of economic relevance.
Absolutely.
And one of those traits, of course, that we're looking at Livestock Gentec is feed efficiency. So trying to identify those animals that have the same amount of production. So let's say the same calves, but eat 2 tons less of feed per year. That's a significant savings.
Oh,
and if you can put 2 of those animals on your place rather than one efficient and one inefficient, you're way ahead.
Exactly. So we're going to come back and we're going to talk about how this information and how this approach is going to affect the industry. And you started talking a little bit about the economic benefits around feed efficiency. Feed efficiency. So we want to get into a little bit more discussion about talking about the wider use and the affordability of some of this reporting as well. So when we come back, we're going to continue with this discussion with Tom and Colin.